Today's topic is insertion sort. Let's see how it works. We have the random data, we have total 7 elements, and we will see how insertion sort will sort them in correct order, in increasing order. So let's start. Insertion sort starts with the second element because it says that the first element is by default sorted. So j starts from 2 and I starts from j minus 1, so it will be 1. So what you do is save the element for which it's going to find the correct position in a variable called key, and then it starts finding its correct position. How it will do, let's see. First, it will compare 6 with the value that is pointing by I, that is 1 index, that is 7. So it compares 6 with 7. Now there is a technical point, let's see what happens. If the previous element is greater than key, what it do, it's not swap both elements. Some students and think that the two values will get swapped. It's not actually like that. Actually, what it has understood is that the previous element has to go one position further because the key element has to get back at least one element. We don't know how many elements back, but at least one element, because we have found one element which is greater than the key element. So what it do is it copies the previous element one position further. Now right at this moment at both places it is also 7 and it is also 7. Now what we do is that key will be decremented, so I will be decremented to 0. As I become 0, there is no more element to compare, so it will enter into the next loop. So j will become 3. Before j will get 3, it will copy the key to its correct position, that is this position. So loop terminates on two conditions. One condition is that while comparing with the previous element, it has found the element which is smaller than the key. Then the loop will terminate. Or the other condition is that there are no further elements to compare, just like what happened that after comparing the key 6 with 7, before 7 there was no element to compare. So loop terminates on the second condition. After the loop terminates, we copy the key to its correct position. Now j is equal to 3, so our key will be now 2, and I will be set again to j minus 1, so it is now 2. Now it compares key with the previous element, which is 7. 7 is larger than 2, so 7 will copy to next position. Then I will be decremented to 1. Then key will be compared to the previous element, which is 6. So 6 will move one position further, and I will be decremented to 0. Now again the loop will terminate on the second condition, that is there are no further elements to compare on the left hand side. So j will be incremented to 4. Before j will be incremented to 4, we will copy the key to its correct position, which is now this. Then when j will be 4, so on index 4, element is also 4. 4 will be compared with 7. 7 is greater, so 7 will move one position further. Before that, I will be reinitiated to 3, and then I will be decremented to 2. Now our key element is compared with the previous element, which is 6. 6 is also greater than our key element, so it will also become 6. I will be decremented to 1. Then we will compare our key with the previous element, which is 2. What will happen? Now the loop will terminate on the first condition. What is the first condition? that the element which we are comparing with the key element is smaller than the key element. You can see 2 is smaller than 4. So it will not further check back. And what will happen? We will copy the key to its correct position, which is this one. Then j will be incremented to 5. I will be reset to j minus 1, which is 4. And what is our key now? It is 3. So we will compare key with the previous element, which is 7. 7 is larger than 3. So 7 will come. I will be decremented to 3. Then key will be compared with the previous element. 6 is also greater than 3. So 6 will come here. And then I will be decremented to 2. Key will be compared with the previous element, which is 4. So 4 is also greater than key. So 4 will. Then what will happen? I will be decremented to 1. And now our key element is not smaller than the element which is pointing by I, which is 3. So we have found a smaller element than key. So what will happen? We will move key to its correct position, which is now this. Next, j will be incremented to 6 and key will be now 5. I will be compared with 7. 7 will move one position further. 5 will be compared with 6 and appropriately I has been initiated to 5 and I becomes 4. So 6 is also greater than 5, so 6 will come here. I will be decremented. Then 4 is not greater than 5. So what will happen? We will copy the key to its correct position, which is this. J will be incremented to 7 and our key will become 8. Now in the very first comparison, we have seen that 7 is smaller than 8. So there will not be any more comparisons before 7. And why is that? Because we know that we have already sorted this range of elements. So if our key element is greater than this element, then key will be definitely larger than all of these previous elements. So that's how insertion sort saves some comparison as compared to bubble sort and selection sort. So if we find the key which is already greater than the previous element, then all of these comparisons will be saved. But in bubble sort and selection sort, these comparisons will not be saved. So that's why in our best case, insertion sort has a better running time, but not in the worst case and average case. We will definitely see in the next video, which is on analysis of insertion sort. Till then, take care.